see, by Leibniz rule of differentiation, we can see that f dash of x equal to small f of under root x square into derivative of x square. This is standard by Leibniz rule of differentiation. So capital F dash of x equal to f of x. Why only x? Because x is positive, so there is no need to take mod and all. If they just said x, suppose there was something like -2, then mod x would have come here, but they said x is positive, so you don't have to take it. So capital F dash of x is f of x into 2x. But it's given in the question that capital F dash of x equal to f dash of x, small f dash of x, I mean. So these two should be equal, right? We'll do that. So what does it say? F dash of x equal to f of x into 2x. That means what? Go to the next page. F dash of x by f of x equal to 2x. Integrating on both sides, what do you get? Integral, suppose a to b. Should take some integral to escape the constants. Or else let's just do indefinite integration. Let's not go to definite integration. What is this? This is ln f of x equal to x square plus c. Correct. Now we'll read the initial conditions. F of 0 equal to 1. Yeah, so small f of 0 equal to 1. So ln f of 0 equal to 0 plus c. But this is 1. So ln 1 equal to c. ln 1 is 0, so c is 0. So it says f of x equal to e power x square. So you need to find capital F of x. Capital F of x equal to integral 0 to f of 2, 0 to 4. Okay, 0 to 4, x square is 4, e power x dx. Why is that so? Square root, no? So that is e power x dx. This is same as e power x from 0 to 4. So it is equal to e power 4 minus e power 0 is 1. So e power 4 minus 1 is the answer. Okay. Okay. Next, we'll go to the second question. It says integral 0 to x under root. Okay, fine. So here also you see x is less than or equal to 1, greater than or equal to 0, and f of 0 equal to 0. Now again, whenever you see such integrals with variables, just differentiate on both. That's the standard technique. Okay. So again, by Leibniz rule, 1 minus f dash of x whole square into derivative of x is 1 equal to f of x. Squaring on both sides, what do you get? 1 minus f dash of x whole square equal to f of f square of x. Okay. So, okay. So 1 minus okay. So f dash of x by under root 1 minus f square of x equal to 1. Correct. Let's continue from here. So integrating on both sides, what do you get? F dash of x dx by under root 1 minus f square of x equal to dx. I mean integration, taking indefinite integrals. But this is the standard form of sine inverse of f of x. This is equal to x plus c. So f of x equal to sine of x plus c. We do not know what c is. We should find out. F of 0 is 0, right? So 0 equal to sine of c, which means what? C should be equal to 0. So f of x equal to sine x. Okay. Now you see for such questions, how you should solve is it involves f of x minus x. See, f of 1 by 3 greater than 1 by 3 or f of half less than half is what? F of half minus half is greater than 0, of f of minus 1 by 3 minus 3 is less than 0. You know, we are initially looking for the sign of f of x minus x for x equal to half comma 1 by 3, correct? So let's investigate the function f of x minus sin x. Huh? Where did I write that? Okay. Okay. So now you see uh, sin x minus x equal to, call it g of x. Okay. What is g of 0? G of 0 is 0. G dash of x is what? Cos x minus 1. Obviously, cos x is less than 1. So this is less than 0. So g is decreasing. G is initially 0 and it is decreasing. Okay. It is decreasing. So g is always negative. So sin x is always less than x. So obviously, sin half is less than half and sin 1 by 3 is less than 1 by 3. So option C is the correct answer because f is sin x. Okay. So this is also an interesting question. Suppose first, okay, this is only involving f, so let's not care about g. F of x is defined this way, then can there be something like this? First, we'll verify if p is correct or not. Okay. So 1 minus x into sin x whole square plus x square plus 2x equal to 2 plus 2x square minus 4x. Okay. So 1 minus x into sin x whole square equal to x square minus 6x plus 2. Can we simplify it even more? Plus x square plus 2x. Okay. Okay, let's not do this step. Okay, let's try to get 1 minus x somewhere, because in that case what happens is you can cancel. This is also correct, but let's try to simplify our problem. So how do you get this way? So 1 minus x into sin x plus x square minus 2x plus 1 plus 4x minus 1 equal to 2 into 1 minus x whole square. So, okay. So 1 minus x whole square is into sine square x plus 1 minus 2 equal to 1 minus 4x. This is sine square x minus 1. Okay, plus 1 minus 2 is sine square x minus 1 into 1 minus x whole square. This is possible, right? Positive into sine square x minus 1 equal to 1 minus 4x. This is possible. There is some x. You can verify it. I mean, the sine square x equal to 1 minus 4x by 1 minus x whole square plus 1 you can do. So there is some x. They did not ask you to find which x. So there you are saved. There exists some x, so p is true. We'll do q. Okay, there exists some x, 2x, 2fx plus 1 equal to 2x into 1 plus x. What is f of x? 1 minus x whole square sine square x plus x square. So f of x equal to 2x square plus 2x minus 1, this entire thing by 2. Okay, this is x square plus x minus half. F of x equal to this. What is that? 1 minus x into sine x whole square plus x square. So 1 minus x into sine x whole square plus x square equal to x square plus x minus half. Okay. So now you see So this thing is always positive, right? Whatever is on the left hand side is always positive, but this is not always positive. So for x less than half, x minus half is less than 0. But they did they mention something like that? See here. Oh, x. Okay. See here, for all x belongs to R. This is very important. For f of x, for all x belongs to R. That means even for x less than half, also this should hold true. Am I getting this? Yeah. But for x less than half, x minus half is less than 0. But this, no matter what, your x is always positive. So Q is false. So you see, sine square x minus 1. See, this is also easy. I mean, you don't have to worry much, because one technique to do is, if the number is less than 1, there exists some x. Okay, 1 minus 4x by 1 minus x whole square plus 1. This is sine square x. So what is this? 1 minus 6x plus x square by 1 minus x whole square. Obviously, this is just x square minus 2x. This is less than 1, no? Because something less than 1 is being divided by something greater. So sin x there exists. So that way also you can think. So they're all techniques. Don't have to solve entire question all the time. Next, we have come to G. So G of x equal to 1 to x 2 times t minus 1 by t plus 1 minus log t f of t. Oh my god. Okay, fine. Shit. Okay. So we should, G is increasing or decreasing, means what is the complete derivative? J of x equal to 2 times x minus 1 by x plus 1 minus ln x. You should also put 1, but you see then this thing becomes 0. So you don't have to do that, into f of x. Now, depending on sign of G, you can decide which of the 4 options. But you know, f is always positive, because some positive number plus positive number, f is always positive. You only have to worry about the sign of this. That is 2 times x minus 1 by x plus 1. That is 2 times x plus 1 minus 2 by x plus 1 minus ln x. So 2 minus 4 by x plus 1 minus ln x. Okay, the sign of this. For x positive, x greater than 1, you see, okay, I'll tell you something. 2 minus 4 by x plus 1 plus ln x. X greater than 1. If x is greater than 1, ln x is always positive. This is also always positive, and they are increasing. They are always positive, right? So log of x is increasing, this is decreasing, but still it's positive. It adds some value always. Okay, increasing plus some value, increasing plus some value. So there is a point for which they cross even 2. So g dash of x is less than 0 after some x, because you said x belongs to 1 to infinity. If they said something like 0 to 1, no, maybe we wouldn't be sure, but x is greater than 1 means what? Log x is an increasing function, right? So there exists some point where it will eventually cross 2 also. This is also a positive number for x greater than 1. So their sum will easily cross 2. So g is always decreasing for 1 comma infinity. Okay. So next comes the 5th question. For a belongs to R and a not equal to 1. You know why did they mention a plus 1 is not 0? A should not be equal to 1. We'll discuss why. So this is trivially seen. Integral is the limit of a sum. So first of all, you should write that sum always as 1 by n times f of r by n. Always try to write it like this, the limitation sum. So firstly, you are seeing r is being varied from 0 to n. So you should get n here. So you can take n common from this and n common from this. What do you get? You get 1 power a plus 2 power a plus so on, so n power a by n power a minus 1 into 1 plus 1 by n whole power a minus 1 into, first we'll sum it, okay, n square a, because na is added n times, plus n into n plus 1 by 2. You multiply, you bring an n common from this, you get what? 1 power a plus 2 power a so on, so n power a by n power a into 1 plus 1 by n whole power a minus 1 into na plus n by 2 plus 1 by 2. So now this is same as summation 1 by n whole power a r by n, r running from 1 to n. You need 1 by 1 more n common, right? Take that from this. Okay, we'll write it here. So this is same as summation r by n whole power a, n running from r running from 0 to n by 1 plus 1 by n whole power a minus 1 into 1 by a plus half plus 1 by 2n. Why is this true? Into 1 by n. See, you need to get somehow 1 by n here. So there is no way you can choose 1 by n common. So take n common from this so that you get 1 by n here. Now what can you write the final equation as? 1 by n times summation r by n whole power a, r running from 0 to n into 1 by a plus half plus 1 by 2n into 1 plus 1 by n whole 1 by 1 plus 1 by n whole power a minus 1. Entire thing taken limit n tends to infinity. Now this can be split into product, but this you know is an integral sum. So this is x power a dx 0 to 1. This is what? This is a plus half because 1 by 2 and this goes to 0 as n tends to infinity. This is 1. Now what is this? X power a plus 1 by a plus 1. So this is equal to x power a plus 1 going limit going from 0 to 1. So it's 1. So this is equal to 1 by a plus 1 into 2a plus 1 into 2. This is given to be 60. So a plus 1 into 2a plus 1 equal to 120. Just search for options. You get 7 and minus 17 by 2 as the answer. It's a quadratic equation, so obviously it will have two roots. Because you see 7 plus 1 is 8. 8 into 15 is 120. Minus 17 by 2 is minus 15 by 2 into minus 70 plus 1 is minus 16. Okay. So this is also there. No? Minus 15. That is also same. So minus 17 by 2 on this thing. Next, we are in the sixth problem. Same again. The less than means for whenever you see summation, see Sn equal to summation k equal to 0 to n by n square plus kn plus n square. See, observe all of them are positive. This is less than summation k equal to 0 to infinity n by n square plus plane plus. This is valid only if this the term being added is always positive. Again, same 1 by n times f of r by n, you should try to get it. How do you do that? This is same as n by n square into 1 plus k by n plus k by n whole square same as 1 by n by 1 plus k by n plus k by n whole square. Correct. This is now integral 0 to 1 dx by 1 plus x square. You know by completing of squares and all, this is pi by 3 root 3. So Sn is less than pi by 3 root 3. Now clearly you see this Tn is always less than Sn. Tn is always less than Sn, but Sn itself, because it's only till n minus 1 terms and all the terms are positive. But Sn itself is less than, so this is also correct. Now, seventh problem, it's a bit complicated problem, but anyway, x comma y says that all these conditions hold. So we'll first decipher what those conditions mean. So firstly, when you take y greater than or equal to square root of mod x plus 3, what do you mean? Y square is greater than or equal to modulus of x plus 3. Suppose x plus 3 is greater than 0 or x is greater than minus 3, then this is, so y square greater than x plus 3 for x plus 3, x greater than minus 3. So y square greater than minus x minus 3 for x less than minus 3. This is one graph. So how does the graph look like? What is x square, y square equal to 4ax something. Y square equal to x minus 3 means what? At x equal to 0, y must be equal to 3. At x equal to minus 3. Okay, this is how it looks like. No? At x equal to 0, y square cannot be minus 3. Okay, it's something like this. Then. Hmm. Y square can never be negative, no? So it just stops here. You won't get something below because that means for y square is greater than this, right? It's greater than minus x minus 3. Hmm. So this is the area first for this. Next, x plus 9 is less than or equal to 15 means what? X is less than or equal to 6. So it's somewhere here. Only till here you should take. This is also okay. And 5y is less than or equal to x plus 9. So y is less than or equal to x by 5 plus 9 by 5. So it has a positive slope and it has a positive y-intercept. So yeah, it's like this, right? Something like this. Okay. And y is less than or equal to. So it should just lie somewhere here. So we'll draw in these points, okay? So this area is what you require. I mean, this, whatever is shared inside this. But this you see, if you find out the points of intersection of x by 5 plus 9 by 5, you get the point here is minus 4 comma 1. Minus 1. Here you get as 2 comma 1. So you can find the area of the trapezium, right? It's half times a plus b times h. So this is the area of trapezium. What is this? Minus 4 to this is 6. Uh, this height is 6 and length of the non-parallel sides half h into a plus b. These two are parallel. So this is 2, this is 4. So 4 plus 2 into 6, that is 118. So this area minus, you should do the integration. Like to find these integrals, you need to you know how to do the integration, right? You know this term, you know this term. So subtracting the center area trapezium minus these two areas will give you just this area. You do all the computations and stuff, you get 3 by 2. See, my main motive was to teach you how to get to the figure, because once you get to the figure, you know f of x minus g of x integral and all those techniques. So drawing the figure is what matters. So this is how we should split initially. So the main motive of this problem was to show you how you should think geometrically and plot the graph correctly, not the computation. Next it is okay. Next, it is the area of region between the curves y equal to under root 1 plus sin x by cos x and y equal to under root 1 minus sin x by cos x, bounded by the lines x equal to 0 and x equal to pi by 4. See, whenever you have sin and cos together, always use the tan formula. What is that? Sin a 2x equal to 2 tan square x by 2. You know, you have this, right? Whenever you have sin and cos in the same formula, use this. So we'll simplify how they behave. So 1 plus what is this? This is same as if you see 1 plus sin x into 1 minus sin x by cos x into cos x, this is 1. Why? Obviously this is 1 minus sin square, which is cos square x, so this is 1. So this is reciprocal of this. So what do you get here? So between the curves, y equal to under root 1 plus tan x by 2 by 1 minus tan x by 2, and reciprocal y equal to under root 1 minus tan x by 2 by 1 plus tan x by 2. See, this is also very simple. This is y equal to under root tan x by 2 plus pi by 4. This is under root y equal to under root tan x by 2 minus pi by 4. Okay, between the lines x equal to 0 to x equal to pi by 4. Or else let's just keep it this way. Let's not use this, because then what you can get rid of the square root sign. So it is 1 plus tan x by 2 minus 1 minus tan x by 2, because I do not know how to simplify to get the final answer. That's the reason. By under root 1 minus tan square x by 2. Correct. This is 2 tan x by 2 by under root 1 minus tan square x by 2 dx equal to integral 0 to pi by 4 to tan x by 2 dx by under root 1 minus tan square x by 2. Okay. That's it, right? Now you put tan x by 2 equal to p. Then what is that final answer you get? 0 to, this is root 2 minus 1, no, tan pi by 4, because 2 tan square theta minus 1 into 2p secant square x by 2 is, what is secant square x by 2? Okay. So secant square x by 2 into dx by 2 equal to dp. So dx equal to 2p. So p into 2p into 2 dp by secant square x by 2 is 1 plus p square into, is 1 plus p square into under root 1 minus p square. So this is 4p dp by under root 1 plus p square into 1 minus p square and root 2 minus 1. So option B is the answer. Next comes the ninth question. X equal to alpha divides the region. So again, in how to do the graphing here. How does y equal to x cube lie? In fact, x cube between 0 to 1 is less than x. Okay. So this is y equal to x. This is y equal to x cube. Suppose line x equal to alpha divides it. That means what? Integral 0 to 1 x minus x cube, not x cube minus x, because x lies between 0 to 1. This is equal to 2 times 0 to alpha x minus x cube dx. Will compute the answer. So that is what x minus x cube means, what? X square by 2 minus x power 4 by 4, 0 to 1 and a half minus 1 by 4 and 1 by 4. So 1 by 4 equal to x square by 2 alpha square by 2 minus alpha for 4 by 4 equal to 1 by 4. Multiplying with 4 on both sides, you get what? 2 alpha square minus alpha for 4 equal to 1. So alpha power 4 minus 2 alpha square plus 1 equal to 0. Huh? 2 alpha power 4. Okay. Oh, I did not do the 2. Sorry. Sorry. You should do 2 here. This is 2 times. Right. Okay. Okay. So multiplying with 4, what do you get? Okay. So 1 by 4 equal to alpha square minus alpha power 4 by 2. Multiplying with 4 on both sides, what do you get? 4 equal 1 equal to 4 alpha square minus alpha 2 alpha power 4. 2 alpha power 4 minus 4 alpha square plus 1 equal to 0. Clear. This is the correct option. This is one of the most thought-provoking question that has ever been asked in the JEE exam. No question has been this thought-provoking. Everything has been like rudimentary formula applications and stuff. This is the only question where you have to use a lot of your brain. We'll see that. So the question is simple: 0 to 1 e power minus x square dx. Now you see 0 to 1 x square is less than x. So minus x square is greater than minus x. E is an increasing function. E power minus x square is greater than e power minus x. So this is greater than integral 0 to 1 e power minus x dx. So which is same as what? 1 minus 1 by e. This is easy. Next, you need a graph. So e power minus x square is a decreasing function. E power minus x is a decreasing function. Suppose say its graph is like this at x equal to 0, it's 1. You do not know where it becomes 0, or else it will never become 0. In fact, it will go something like this. It is decreasing function. Okay. Let's stop it at 1. Now you see at x equal to 1 by 2, 1 by root 2, what is the value of y? 1 by root 2. If you put e power minus 1 by root 2 whole square, it's e power minus half, that is 1 by e power half, that is 1 by root t. So at x equal to 1 by root 2, its value is 1 by root t. So let's complete these rectangles, okay? So this entire area under the curve is less than the sum of areas of these two curves, right? What's the area of these two? This rectangle, it is 1 by root 2 into 1 minus 1, 1 by e, correct? What is this? This is 1 by root 2 into 1. Okay, sorry. This is 1 by root 2. Area of this entire rectangle is 1 by root 2 into 1. Plus, this is still here, it's 1 by root 2. This is 1 minus 1 by root 2 into, what is the height? 1 by root e. The entire thing is 1 by root 2 plus 1 by root e into 1 minus 1 by root 2. So option D is also the correct option. So we have so see, the only thing which we have seen in this entire topic of discussion is how to use geometry to solve problems in areas and rectangles. Okay, areas, integration everywhere, and there are some more common properties also, like integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. It has become so common that they have stopped giving such questions in JEE because everybody knows that technique now. So our main aim in this session was to give you techniques which are geometrically motivated and help you in solving the problems. That's why I drew all the figures, you know, always figure here, figure here. Just this one requires no figure, but others all do require, see, figure, limit, integral, limit. So the only two important concepts are geometry and the integral as a limit of a sum. Integral of limit of a sum is a very important question. This is a trivial question. Just knowing the Leibniz formula would help.